Welcome back. So many of you asked me to put week 8 assignment answers. So that's why I am posting week 8 assignments soon after week 1 assignment. I'm starting with question number 9 because only after if you understand this question you can answer other questions. So let's start. In question number 9, they are asking which of the statements are correct. First of all, you want to know if any transaction commits just before the checkpoint, we can ignore them. That means they are already committed. They don't want to do anything, even if a system crashes. Now, in this picture, we have two checkpoints and a system failure at the end. We can see that T1, T2, T3, no, not T3, T1, T2 and T4 are committing just before the last checkpoint. So we can ignore them. And the transaction which committed just before system failure and after the checkpoint should be redone. So here we can see T3 committed just before system failure and after checkpoint 2. And what about T6? It also should be redone because it committed before system failure and after checkpoint 2. And see T5. T5 didn't commit, so it should be undone. So what will be the answer? Check 1. Check 1. T1, T2 and T4 can be ignored. T1, T2 and T4, yeah. All the three committed before checkpoint 2. So it can be ignored. So 1 can be correct answer. What about 2? T1, T2 and T3 can be ignored. T1, T2 and T3, no. T3, no. T3 just before system failure it committed. So it should be redone. What about T3 and T6 needs to be redone? T3 and T6, yeah, I already said T3 and T6 committed before system failure, so it should be redone. So option the 1 and 3 are correct. What about 4? T3, T4 and T6 should be redone. No, because T4 committed before checkpoint 2 and T6 only T3 and T6 need to be redone, and T5 need to be undone. I already said that. So what will be the answer? 1, no, 1, 3 and 5. 1, 3 and 5 will be the answer. Option B. Now let's go to the first question. Yeah, here. The first question they are asking, the system crashes just after step 14 and the recovery of the system is completely done. What will be the correct actions? Here let's check the log records. T0 started and T0 committed before checkpoint, right? T0 started at step 1 and committed at step 5 just before the checkpoint T1. So T0 can be ignored if system crashes. What about T1? T1 started, it had some transactions in step 4 and when it is committed is step number 8. Step number 8. So after that no checkpoints are seen, so it should be redone. What about T0, T1 completed, okay, and T2 started at step 7. Then T3 started, T4 started, T2 has some transaction, T3 also has a transaction. They didn't commit, right? Then after that T4 has some transaction and T2 committed. T3 and T4 didn't commit before system crashes. So T3 and T4 should be undone. So what will be the correct answer? Check option A. The value of x will be 300. x. Which transaction do changes in x value? T0, right? T0 committed before checkpoint T1. So the final value of x will be 500. Here the option is in this 300 is given, so option A is not correct. What about option B? Y will be 600. Which transaction is holding Y? T1, right? T1 T1 600. T1, when did it commit? After checkpoint and before system crashes. So it will be reader. So the final value of Y will be 600. Therefore option B will be correct. What about option C? Option C, W will be 300. W3 T3 T3 is not committing, so it should be undone. So the value after recovery will be 300 itself. So option C will be correct. What about option D? V will be 100. V will not be 100, right? T4 is not committing. So the option B and C are the correct answers. Let's do similar questions first. So I'm moving to question number 3. Here, which are the correct answers? Let's look to the log records. Here T1 started, T2 started, and T2 is committing before checkpoint T1, and T3 starting. T1 and T3 is committing before system crashes, and then T4 is not committing. So T2 can be ignored because it committed before checkpoint. T3 and T1 committed before checkpoint before system crashes, so it should be redone, and T4 should be undone. So what will be the right answer? It should be B. Now let's see question number 6. Question number 6, it uses P plus 3 based concurrency control. Means they have something like operation begin and operation end. It gives, see here, they says that if system crashes, what should be done to the value. Here it says that if system crashes, the value set should be decreased by minus 500. Here 700 is the final value of set, and if system crashes at step number 10, the value should be decreased by 500, means it should be decreased to 200. Find the correct answer here. In which option it is changed to 200? It's option B and C. Option B and D, right? In B and D, 700 is changed to 200. And then let's see T1 comma Y comma 200. What happens to the value of Y? Which transaction hold Y? Transaction T1 holds Y here, right? And T1 started, T1 changes the value of Y from 200 to 500, and then it didn't commit, right? It didn't commit and the system crashes, so the value should be 200 itself. So which option gives 200? Option B, right? In option D, it is value 500. It should be 200. So the option B is the correct answer. I'm skipping question number 5 and 10 because it is a direct question from the lecture note. Please refer lecture notes, okay? And I will add the link to this PDF down in the description. You can refer from that note also. Now I'm going to question number 7 because many of them have some doubt in clearing this question. Here two query trees are given and they are asking which correct statement from the given option. In option 8 it says both query trees are equivalent. Let's check. I have these are query trees and I converted them to relational algebra. Let me show you. See this? I converted first query tree to the first one and the second query tree to the second one. These both are correct, right? See the first one. From courses, they select the tuples with course name IT, and that is joined to the table registration and then joined to students, and from that student name is projected. That is same to the down right. Course and registration is joined and the tuples with course ID is selected, and from that it is joined to the table students and student name is finally projected. These both are same, so the query trees both are equivalent here. And the next option which is correct is query trees are equivalent and the query tree figure 1 will lead more efficient query processing. Option C. Why? Why? Because here, see, here selection is done before we join the table. In the second tree, join is done and then is selection done. As fast as possible we should do the selection, then only it the query tree will be efficient. Similarly, projection also, if we use projection before joining two tables, it will be more efficient, and that's the reason I selected first query tree, more efficient. You got the answer, right? That's why A and C become more answers. Now move on to question number 8. Question number 8. Which are the correct queries, right? I hope you can do this by yourself, right? Now here the answer is given A and C. I'm not wasting time, just giving the answer why how this get. A, Q1 is equivalent to Q2. In Q1, student and registration is joined, and from that tuple with semester fall 2023 is selected, and from that student name and email is projected. What about Q2? In Q2, from registration semester with fall 23, the tuples are selected, and then that tuples and the student is joined, then student name and email is projected. Both are same, right? That you can understand, you studied the lectures, right? What about Q3 and Q4? Course and registration are joined, and from that tuples with semester spring 23 is selected and course name is projected. Second one, tuples with semester spring 2023 is selected, and from that only course ID is projected, and course table and this course ID, the set of the course ID is joined. Then you will get a table with all the values of courses with same course IDs, and from that you can select the name. So Q3 and Q4 will also be equivalent. Now let's look question number 4. Here we have a condition given. Identify the required number of block transfers and 6. If the smaller relation fits entirely in memory, use that as the inner relation using nested loop join. In the lecture notes, we already studied such that if the smaller relation fits entirely in memory, use that as the inner relation. Reduce the cost to BR plus BS blocks transfers and 2 6. BR plus BS. So the equation is BR plus BS. Here, which are the BR and BS? We have two block transfers here. Which are they? The number of blocks of books 300 and number of blocks of authors 30. So these are BR and BS. So adding them we get 300 plus 30, 330 block transfers and 26. So the answer is option C. Now moving on to the final one, question number 2. What is the cost estimation? We have a formula. See this? The formula is B star TT plus S star TS. Here B means the number of blocks and TT gives transfer of time to transfer one block. The capital S gives the number of seeks and TS gives number of the time for one seek. So the answer will be, it is a direct question, right? So the answer will be 1000 into 4 milliseconds should be converted to second. 1 millisecond is equal to 0.001 second. So you should convert 4 millisecond to seconds, that is 0.004 second. So 1000 into 0.004 seconds plus 30 into 0.3 second, we get 13 seconds, that is option B. So this is week 8 answers. If you have any doubts, please comment down. Okay, thank you.